And in this video we are learning how to carry out differentiation of trigonometric functions. So let's get started with the objectives. I'm looking for you as a student to be able to find the derivative of trigonometric functions and also apply all the previous rules that we've worked with, those like the power rule, the product rule, the quotient, and the chain rule if necessary. So let's get started here. You all have already been introduced to these two trig functions. The derivative of the sine function is cosine of x, and the derivative of cosine is the opposite of sine of x, or whatever. It might be theta. It would just depend on the variable that you're working with. But now using these and a trigonometric identity, we are going to derive the rest of your trig functions because there are 6 of them. So we only have 2, and we're going to use this trig identity, the fact that sine squared plus cosine squared equals 1, to find them. So let's get started here. Tangent of x. Let's rewrite this in terms of sine and cosine. That would be sine of x over cosine of x. Now, that would require us, if we were trying to find the derivative, to use the quotient property. That would be the derivative of the numerator, which is cosine, times the denominator, which is cosine, minus the numerator times the derivative of your denominator. That's going to be sine and then a negative sign, all over cosine squared. This, when you multiply cosine and cosine, will give you a cosine squared, and when you multiply the negative sign and the negative sign, it'll be a positive sine squared all over cosine squared, and that numerator is our trig identity. So we could rewrite that as just 1 over cosine squared of x. And if you take the reciprocal, that would just be secant squared. So the derivative of tangent is secant squared. All right, that's the first one. We have a few more. Now let's do cotangent. Right, so now when we write cotangent in terms of sine and cosine, it's going to look like cotangent. Cotangent will look like tangent, but just flipped. So now it's cosine over sine. Now using the quotient property, the derivative of the numerator is negative sine x times the denominator, which is sine x, minus cosine x, that's the numerator, and the derivative of your denominator is cosine x as well, all divided by sine squared x. When we simplify, you'll have a negative sine squared x minus cosine squared x, all over sine squared x. If you look at that numerator, it is much like your identity, except that both the sine and cosine are negative. If we just factored out that negative, then you would have negative times 1. So that would be a negative 1 in the numerator all over sine squared x. And sine squared, when you take the reciprocal of that, is cosecant. So we're looking at negative cosecant squared x. That is the derivative of the cotangent function. Couple more here. Now let's find let's derive the derivative of the cosecant function. Writing it in terms of sine and cosine, it would be the reciprocal of sine, 1 over sine. Now, using your quotient function, or your quotient rule, it would be 0 times, because the derivative of your numerator is 0, 0 times sine x minus 1 times the derivative of sine, which is cosine, all over sine squared x. Now that's really just negative cosine x over sine squared x. And at this moment, you can't really simplify, you can't really use that trig identity, but we can expand your denominator. So what this really could be interpreted as is negative 1 over sine and cosine over sine, which is, using your trig definitions, negative cosecant x times cotangent x. And that is the derivative of cosecant. The last one is secant. And secant, if you've written in terms of sine and cosine, is just the reciprocal of cosine. And again, we use our quotient rule to find the derivative. And you're going to have 0 times cosine minus 1 times the opposite of sine, all over cosine squared, which gives you sine over cosine squared. And again, we're going to kind of expand this out, and we'll see that 1 over cosine is secant and sine over cosine is tangent. So the derivative of secant is secant x tangent x. Those are now all of your trig functions' derivatives. Now let's try some examples using all the previous rules as well as these trig rules. 5 times sine x, that's really just 5 times the derivative of sine, because you're taking and using that product when you take and multiply just by a number times a function. It's just that number times the derivative of that function. You can see that in the previous sections. Now example 6 is a little different, because really what you're looking at is a function inside of a function. This is an example of the chain rule. It would be cosine of then 4x, and then the derivative of that inside function, which is 4x. The derivative of 4x is just 4, which you would simplify and write 4 times cosine 4x. This next one, you could rewrite it. It is made a lot easier when you write it like this. It is sine x squared. So you have a function squared. This is again an example of your chain rule. So you take the derivative of that outside function with the inside function as your input, and then take the derivative of that inside function. The derivative of sine is cosine. And you could just simply write this without the parentheses, 2 sine x cosine x. All right, now example number 8. Sorry about that. You could rewrite this as sine 4x squared. So we have an inside function being squared. That means you're going to really use example 6, because we already found the derivative of sine 4x. That is your inside function. This is really cool. This is the chain rule applied twice. You take 2 times the inside function. That's that outside function's derivative with the inside function still plugged in. And then you take the derivative of the inside function, sine 4x, which is cosine 4x times 4. You can simplify this. It would be 8 sine 4x cosine 4x. I think that's just so cool, personally. Let's look at some more. Again, I would encourage you to rewrite this. This is really sine of x to the 1/2 power, which is going to be an application of your chain rule. You take the derivative of the outside, the derivative of sine, which is cosine, and then keep that inside function, and then take the derivative of that inside function of x to the 1/2 power, and it is 1/2 x to the negative 1/2 power. which can be simplified. You would have cosine times the square root of x in the numerator, and it would be divided by 2, and then you would remove the negative power for your x. It is in the line above, it's x to the negative 1/2. You would remove that by putting it as a root in your denominator. Now let's contrast number 9 with number 10. This is a little bit different. Now you're taking the root of your whole function. So now the outside function is different. The outside function is the sine x that is inside, and the outside is the function to the half power. So you're going to have 1/2 inside function to the negative 1/2 power times the derivative of your inside function. The derivative of your inside function of sine is cosine. Now to simplify this, your cosine function stays in the numerator, 2 is in the denominator, and now you're taking the square root of sine x and putting that in the denominator so that your power is positive. All right, 11. Rewriting this. This is really the previous problem, but then the chain rule is applied twice here again. So the outside function is you're taking the sine 4x and raising it to the half power. So when you take the derivative of that, it would be 1/2 sine 4x, and then you decrease your power by 1, so it'll be negative 1/2. Now, you're looking back up to your previous problems. The derivative of sine 4x is cosine 4x times 4, because you have to take the derivative of that inside function of 4x. 4x is the function inside of your sine function. Now let's simplify this. You're going to have 4 in the numerator, so 4 divided by 2, that gives you the 2 in front of the cosine 4x, and then the sine 4x to the negative 1/2 power, you can write that as the root in the denominator. All right, example 12, and this is going to be the last one for this video. I'm going to do 2.7 in another part, so this is going to be the last of part 1. So sine x, cosine x. This is going to be a product rule, so that would be the derivative of the first times the second plus the first times the derivative of your second, which is cosine squared minus sine squared. All right, so thank you. If you had any questions on this first part, please put little question marks next to them so that we can go through them together. And stay tuned for part 2. Thanks.